Hello everyone, this is me Ataullah Shafiq and I am your instructor for this course. First of all, I have to discuss about the schedule and timing. So basically we will share you the video recordings firstly for lectures and in which you have to be familiar with briefly overview for topics. Then we will schedule a live session either on Zoom or uh, like Google Meet and discuss these topics in the depth, right? Uh, as well as the practicals. So in pre-recorded videos, you have given some questions, and you need to drop your answers in comment box. Basically, this is mandatory for you all, right? So now I start with the name of God, who is most beneficial and the most merciful and the creator of all cosmos. Uh, so welcome to the first course to CCNA 7, Introduction to Network. This is the first of three courses that are the part of CCNA certification exam. Basically, this course contains the 7 modules, each with a series of topics. Okay. So here is the module objectives, which we will discuss throughout this course and this lecture. So just we discuss the advances in uh, modern technologies. So our first object is network affect our lives. How network affect our lives. Among all of the essentials for human existence, the need to interact with others rank just below our need to sustain life. Communication is almost as important to us as our reliance on air, water, food, and shelter, right? So, in today's world, through the use of networks, we are connected like never before. People will ideas can communicate instantly with others to make those ideas a reality. Like news events and discovers are known worldwide in seconds, right? So individuals can even connect and play games with friends separated by oceans and by the networks. No boundaries. So basically, advancements in networking technologies are the most significant changes in the world today. They are helping to create a world in which national borders, geographic distance, and physical limitations become less relevant, and the presenting ever dimensions, obstacles, and others, right? So the internet has changed the manner in which our social, commercial, political, and personal interactions occur. The immediate nature of communications over the internet, the creation of global communities. Global communities allow for social interaction that is independent for location or time zone, right? The creation of online communities for the exchange of ideas and information has the potential to increase the like productivity opportunities across the globe, right? So the creation of the cloud lets us store documents and pictures and access them anywhere anytime. So whether we are on a train, in a park, or standing on top of a mountain, we can access our data, and we can access our applications on any device. So now we discuss about network components. First of all, host roles. If you want to be a part of a global online community, your computer, your tablet, your smartphones must first be connected to a network. This is mandatory to all of you, right? So that network must be connected to the internet. This topic discuss the part of a network. See if you recognize these components in your own home or school network. So, all computers that are connected to a network and participate directly in network communication are classified as the hosts. Basically, host can be called end devices. Some hosts are also called the clients. However, the term host especially refer to the devices on the network that are assigned a number of communication purpose. This number identifies the host within a particular network. This is the number is called the IP, Internet Protocol Address, right? We will discuss about IP later. So an IP address identifies the host and the network to which the host is attached, right? Basically, servers are the computers with software that allow them to provide information like emails, like web pages, to other end devices on the network. Each service required a separate server software. For example, a server required web server software in order to provide web services to the network, and a computer with server software can provide services simultaneously to many different clients. So, as mentioned before, clients are a type of host, right? Client have software for requesting and displaying the information obtained from the server, like as shown in this figure. So basically, an example of client software is a web server, like Chrome, like Firefox, like other browsers. A single computer can also run multiple types of client software. For example, a user can check email and view a web page, while instant message and listen to an audio stream, right? So, and number three is the table lists three components types of server software, like email, like web, like files. Other network components is peer-to-peer. Peer-to-peer, basically clients and server software usually run on separate computers, but it is also possible for one computer to be used for both roles at the same time, client and server. In small network and homes, many computers function as the servers and clients on the network. This type of network is called a peer-to-peer network. In figure, you can see this in screen. The print sharing a PC has a universal server serial bus USB. We can say uh, connection to the printer and a network connection using a network interface card called NIC to the file sharing PC. And here is the some advantage and disadvantages of the peer-to-peer networking. Easy to set up. This is one of the main advantage of the peer-to-peer networking, and it's a less complex and also lower cost because network devices and dedicated servers may not be required, like, and it can be used for simple tasks such as transfer file and share uh, printers and some other devices and devices, right? So and disadvantages of the peer networking is no, it is no as the secure and not as the scalable, like other networking blocks, right? And its all devices may act as both client and servers, which can slow their performances. Now, end devices. So basically, the network devices that people are most familiar with are end devices. So each end device on a network has an address basically. When an end device initiate the communication, it uses the address of the destination end devices to specify where to deliver the messages. So an end device is either the source or destination of a message transmitted over the network. So, in short, data originates with an end device, flows through the network, and arrives at an end devices. Intermediary devices is connect the individually end devices to the network. They can connect multiple individual networks to form an internetwork. These devices provide connectivity and ensure that data flows across the network, right? So these type of devices use the destination and device address in conjunction with information about the network interconnections to determine the path that messages should take through the network. Example of more common intermediately devices and a list of functions are shown in this figure. So in this picture, not shown is a legacy Ethernet hub. An Ethernet hub is also known as the multi-port repeater. Repeater regenerate and retransmit communication signals. Notice that all intermediately devices perform the function of a repeater basically. Now, network media. Communication transmits across a network on media, and the media provides the channel over which the messages travels from source to destination, right? So modem networks primary use three types of media to interact devices as shown in figure. Number one is metal wires within cables. Number two, glass or plastic fibers within the cables. That called fiber optics cable, right? And number three, wireless transmission. So basically, different types of different media, network media have different features and benefits. Not all types of network media have the same characteristics, and nor they appropriate for the same purposes. Okay, right? So the four main criteria for the choosing network media are these: the what is the maximum distance that the media can successfully carry a signal, and number two is what is the environment in which the media will be installed, and number three, what is the amount of data and at what speed must it be transmitted, and finally, not least, but what is the cost of the media and the installations. So now our third objective is network representation and the topologies. So basically, network administrators must be able to show what their networks will look like, right? They need to be able to easily see which components connect to other component, where they will be located, and how they will be like connected. And diagrams of the networks use symbols like those shown in the figure to represent the different devices and the different connections that make up a network, like end devices and network media and intermediate devices and others. So a diagram provide an easy way to understand how devices connect in a large network. This type of picture of a network is known a topology diagram. The ability to recognize the logical representation of the physical networking component is critical to being able to visualize the organization and operation of a network, right? So in addition to these representations, is used to describe how each of these devices and media connect to each other. So here is the topology diagrams. Basically, it is mandatory documentation for anyone working with a network. They provide a visual map of how the network is connected. There are two types of topology diagrams. Number one is physical and number two is logical. So basically, physical diagram illustrate the physical location of intermediate devices and cables which installation as shown in the first figure. You can see that the rooms in which these devices are located are labeled in this physical topology, right? So number two is logical topology diagram. It is basically illustrate devices, ports, and the addressing scheme of the network as shown in the figure. You can see which end devices are connected to which intermediate devices and what media is being used, right? So the basically the topologies shown in the physical and logical diagrams are appropriate for your level of understanding at this point in the this course. Search the internet for network topology diagram to see some more complex examples. If you add the word Cisco to your search bar, you will find many topologies using icons that are similar to what you have seen in these figures. Now comes to our fourth objective, common types of network. Now that you are familiar with the components that make up networks and their representations in physical and logical topologies, you are ready to learn about the many different type of networks, right? Networks come in all sizes. They large from simple networking consisting of two computers to network connecting million of devices. Some home networks let you share resources such as printer, such as documents, pictures, and music among a few local and devices, right? So, small office and home office networks allow people to work from home or a remote office. Many self employed workers use these types of networks to advertise and sell products, orders, and communicate with customers and other type of communications, right? So business and large organizations use networks to provide basically storage, access, information on network servers, and networks provides emails, instant messages, and collaboration among employees. Many organizations use their networks connection to the internet to provide products and services to customers. So the internet is the largest number existence. In fact, the term internet means a network of networks, right? Internet means network of networks. It is a collection of interconnected private and like public networks. In small business and homes, many computer functions as both servers and clients on the network. This type of network is called the peer-to-peer network, as I mentioned earlier. Now, LANs and WANs. The two most common types of network infrastructures are local area network and wide area network. A LAN is a network infrastructure that provide access to users and end devices in a small geographic area. A LAN is typically used in a department within an enterprise, a home, or like small business network, right? And WAN is a network infrastructure that provide access to other network over a wide geographic area, which is typically owned and managed by a larger corporation or a telecommunications services provider. As shown, show LANs connected to a WAN. So, a LAN is a network infrastructure that spans a small geographic area, as I mentioned. It has specific characteristics like LANs, interconnected and devices in a limited area, such as home, such as office, building, school, and campuses. A land is usually administered by a single organization or the as well individual. So administrative control is enforced at the network level and governs the security and access control policies. And other one is LANs provide high speed bandwidth to internet and devices and also the intermediate devices, and the WAN interconnects two LANs, right? like in figure. A LAN is a network infrastructure that spans a wide geographic area and typically managed by the service provider or internet service provider (ISPs). Uh, and Once interconnected LANs over wide geographic area, such as cities, such as states, provinces, countries, continents, and like that. And WAN are usually administered by multiple service providers, uh, and it typically provides slower speed links between LAN. Now, the internet. So, basically, the internet is a worldwide collection of interconnected networks, the figure shown. One way to view the internet as a collection of interconnected LANs and WANs means some of the lens examples are the connected to each other through a WAN connections. WAN are then connected to each other. The red WAN connection lines represent all the varieties of ways we connect networks, and WAN connects can connect through copper wires, fiber optics, cables, wireless transmission, and others, right? And the internet is not owned by any individual or group, ensuring effective communication across this diverse infrastructure requires the application of consistent and commonly recognized technologies. Then there are two types and two other terms which are similar to the terms internet. Which one is intranet and second one is extranet. So intranet basically is a term used to refer to a private connection of LAN and WAN that belongs to an organization. An intranet is designed to be accessible only by the organization's members, employees, and other with the authorization. An organization may use an extranet to provide secure and safe access to individuals who work for different organizations but require access to the basically organization's data. So the figure illustrates the basic levels of access that different groups have: a company intranet and company extranet and the internet. Our fifth objective is the internet connections. So now you have a basic understanding of what makes up a network and different types of network, but how do you actually connection users and organizations to the internet? As you may have guessed, there are many different ways to do this. Home users, remote workers, and small offices typically require a connection to an ISP to access the internet connection. Connection options vary greatly between ISPs and geographical locations. However, popular choices include broadband cable, broadband digital subscriber line (DSL), and wireless WANs and mobile services. So, organizations usually need access to other corporate sites as well as the internet. Fast connections are required to support the business services, including IP phones, like video conferencing and data center storage. Now, home and small office internet connections. This picture, this figure illustrates the common connection options for small office and home office users. These are the common terms which you familiar with these: cable, DSL, cellular, satellite, and dial-up telephones. Now come on the business internet connections. Basically, corporate connection options differ from home user options, right? Business may require higher bandwidth, dedicated bandwidth, and also the managed service, right? So connection options that are available differ depending on the type of services providers that located nearby. So this figure illustrates the common connection options for the business. Number one is dedicated line, leased line. Dedicated leased line are the reserved circuit within the service providers that connect geographically separated offices for private voice and data networking, right? So these circuits are rented at monthly or yearly rate. And other is metro ethernet. This is sometimes known as the ethernet WAN, right? So number three is business DSL. It is available in the various form. A popular choice is symmetric digital subscriber line. We will discuss about this later. And number four is the satellite. It is the service can provide a connection when a wired solution is not basically is it is not when available, right? So now how covering network. Basically consider a school built 30 years ago. Back then some classroom were cabled for the data network, telephone network and video network for televisions. These separate networks could not communicate with each other, right? So each network used different topologies to carry the communication signal, and each signal had its own set of rules and standards to ensure the successful communications. Multiple services ran on multiple networks. Today, the separate data, telephones, and video network coverage, unlike dedicated network, are capable of delivering data, delivering the voice and video between many different types of devices over the same network infrastructure, right? So this network illustrate the use the same set of rules, the same set of agreements and the implementations standards, and it's covered the data network carry multiple services on one network, right? As you can see in this figure. Now, our sixth objective is the reliable networks. As you know by now, the internet did not go down. You just lost your connection to it, right? It is very frustrating with so many people in the world relying on network access to work and learn. So it is the in this context, reliability means more than your connection to the internet, right? This topic focuses on the four aspects of the network reliability. The role of the network has changed from a data only a network to a system that enables the connections of people's devices and information in a media rich, right? So, for networks to function efficiently and grow in this type of environment, the network must be built upon a standard network architecture. And networks are also support a wide range of applications and services. They must operate over many different type of cables and devices which make up the physical infrastructure. The term network architecture in this context refer to the technologies that support the infrastructure and the programmed services and rules and protocols that move data across the network. We have learned that there are four basic characteristics that network architects must address to meet user expectations, like quality of service, number two, security, number three, fault tolerance, and number four is scalability. So basically, fault tolerant network is one that limits the number of affected devices during a failure. It is built to allow quick recovery when such a failure occurs. These networks depend on multiple paths between the source and destination of a message. If one path fails, the message are instantly sent over a different link. Having multiple paths to a destination is known as redundancy, right? And implementing a packet switch network is one way that reliable networks provide the split traffic into packets that are routed over a shared network. Uh, So, a single message, such as an email or a video stream, is broken into multiple message blocks called packets. Each packet has the necessary addressing information for the source and destination for the message, and the routers within the network switch the packets based on the condition of the network at that moment. This means that all the packets in a single message could take very different paths to the same destination. In this figure, you can the user is unaware and unaffected by the router that is dynamically changing the route when a link when the link is fails, right? Now, a scalable network expand the quickly to support new users and applications. It does this without degrading the performance of services that are being accessed by existing users. The figure shows how a new network is easily added to an existing network. These networks are scalable because the designers follow the accepted standards and the protocols. This lets software and hardware focus on improving products and services without having to design a new set of rules and operating within the network. And quality of service is an increasing requirement of networks today. New applications available to users over network, and such as voice and live video transmissions, create higher expectations for the quality of the delivered services, right? So, have you ever tried to watch a video with constant breaks and pauses? No or yes? As data, voice, and video content continue to coverage onto the same network, so quality of service becomes a primary mechanism for managing congestion and ensuring reliable delivering to content to all users. When the volume of traffic is greater than what can be transported across the network, devices will hold the packets in memory until resources become available to transmit them, right? So in this figure, one user is requesting a web page and another is on a phone call, right? With a quality of service policy in place, the router can manage the follow of data and voice traffic, giving to voice communication in the network experience congestion. The focus of quality of service is to time sensitive traffic, the type of traffic, not the content of the traffic, right? Is what is important. Now, network security in this infrastructure, services, and the data content on network attached devices and personal and business assessed, right? So, network administrator must address two types of network security concern: network infrastructure security and information security. So, securing the network infrastructure includes the physical securing devices that provide the network connectivity and unauthorized access to the management software that resides on them. You can see in this figure. So, network administrator must also protect the information contained within the packets being transmitted over the network and the information stored on network attached devices. In order to achieve the goals of network security, there are three primary requirements. Number one, confidentiality and integrity and availability. Uh, Confidentiality means data confident means that only the intended and authorized can access and read the data, right? And integrity means data and users that the information has not been altered in transmission from origin to the destination, right? So and availability assures the users of timely and reliable access to data services of authorized user. Now our last objective is the network security. Network security is an integral part of the computer networking, regardless of whether the network is in a home with a single connection to the internet or is a corporation or with thousands of users. Network security must consider the environment as well as the tools and requirements of the network. It must be able to secure data while still allowing for the quality of service that users expect of the network. Securing a network involves the protocols and technologies, devices, tools, and techniques in order to protect data and the threats. Means threat vectors may be external or the internal, right? So many external network security threats today originates from the internet. There are several common external threats to network: viruses, worms, and others, spyware, adware, zero-day attacks, actor attacks, denial of service attack, and identity theft. So we will discuss these all in details later. But till now, there have been many studies that show that the most common data branches happen because of internal users of the network. This can be attributed to lost or stolen devices, accidental by employees, and in the business environment, even the malicious employees with the involving the some BYOD strategies. Corporate data is much more uh, uh, valuable, right? So therefore, when developing a security policy, it is important to address both external and internal security threats, uh, as shown in figure. Now, the solutions for the security. Basically, a home network security implementation is usually the rather basics. Typically, you implement it on the end devices as well as the uh, point of connection to the internet, and can even rely on contracted services from the ISP, right? So these are the basic security components of a home or a small office network, right? Like antivirus and spyware softwares, and also firewalls, right? And in contrast, the network security implementation for a corporate network usually consists of many components built into network to monitor and filter traffic. Ideally, all the components work together, which minimize the maintenance and improves the security. Larger networks and corporate networks use antiviruses, anti-spywares, and firewalls, but they also have other security requirements like access control layer (ACL), dedicated firewall system, and intrusion IPS intrusion prevention systems, and virtual private networks VPNs, like, right. So network security requirement must consider the environment as well as the various applications and the computing requirements. Both home and business environment must be able to secure their data while still allowing for the quality of service that user expect of each technology. So the study of network security threats and the techniques starts with a clear understanding of the underlying switching and routing infrastructure used to organize network services. Here is the today's activity for you. You need to drop your answers in comment box. This is mandatory for you, that you must be drop your answers in comment box. Okay. So thank you so much for your time, and stay blessed and